Okay. All right, so we're going over the first homework problem, and we just wrote the electronegativity numbers. So we have 3.5 for oxygen, 2.5 for carbon, and then 2.1 for hydrogen. Now we need to do the subtraction, the difference of all of these. So the first one here is 3.5 for oxygen minus the 2.5 for carbon, and that's going to give us 1.0. So if you remember, anything between 0.4 and 1.9 can be polar. That's kind of our polar range. And so what we usually do is we'll draw an arrow towards the element that has the higher electronegativity, or the higher number in this case. And the other one would get kind of the tail of it with a little plus there, just kind of showing that this is probably going to be the negative side if everything works out. And then the other side is going to be more positive. Now, we have to look at the rest of the molecule as well, because you usually don't put a charge in the center of it. It's usually on the ends. So let's take a look at the hydrogen, which is 2.1, and the carbon, which is 2.5. So if we subtract those, we get 0.4, and that could be potentially polar, right? It's somewhere between 0.4 and 1.9. And if this was just a hydrocarbon, we would say it's nonpolar, but because it has that oxygen in there, that's going to change some things. So if you take a look here, the arrow would go from the hydrogen to the carbon for both of these, because both of these have a lower number, the 2.1, and the carbon's at 2.5, the higher number. So now that we have this kind of like these arrows in here, can you determine that one side of this molecule is going to be negative and then one side's going to be positive? Or like, does one side have a higher number and the other side have a significantly lower number? And with that, yeah, we can. And that's going to help us determine that this is a polar molecule. So whenever you see something like this, where you have this overall kind of like movement of electrons, so like going from this low number to this higher number, that's going to give you the indication that it's going to be a polar molecule. So what we would do here is we'd put the slight negative near the oxygen, and then these slight positives over by these hydrogens here. And we would also say that this is polar. So again, you're looking for a general move in one direction of the electrons. And in this case, they're all kind of moving to the right. Okay, any questions with that one? All right, cool. All right, so let's check out the next one. Okay, so for this one, we already figured out all this, the shape and the angles and all that. So here we have hydrogen, which is 2.1, carbon, which is 2.5, and then nitrogen, which is 3.0. Okay, so we do see a trend of numbers increasing as we move across here, but we do want to figure out the differences. So I'm going to draw an arrow in this direction because 3 is higher than 2.5. I'm going to subtract, and that's going to give me 0.5, which just those two tell us that it's probably going to be polar because it's moving in that one direction to the right. It's higher than, 0.4. Because again, remember, from 0.4 through 1.9, it's going to be potentially polar. If it's 0 to 0.3, then it's going to probably be nonpolar. Okay, another thing. Now we do the same thing for this one, and we can see that we're still moving to the right here. And in this case, it's going to be 0.4. So you can kind of think of this as overall, it's moving in 0.9. All right, so it's all kind of moving across, all going in the same direction here. So same as the last one here, wherever the arrow is pointing to, that's going to be the negative side. And then the other side is going to be the slightly positive side. And you can put the little plus signs over there, kind of showing that that's the positive side as well. All right. Okay, any questions with that one and figuring out the polarity for it? All right. Okay, and then we have this one. And we're missing a dot, so let me put that in there. All right. And we have 2.1, 2.5. Oxygen's 3.5. And all the hydrogens are 2.1, so I'm just filling it in real quick. All right, and again, we can see like a flow towards the oxygen, right? Remember, I said if you see an oxygen, it's going to probably make it more polar. Now, there are exceptions to that, but as you can see here, we have it moving in this direction by 1.4. We have it moving in this direction from the carbon to the oxygen by 1. And then all of these hydrogens are also going to be moving in towards there, but less important. because, you know, they're kind of further away, but that's okay. We see overall that this is the high number and that most of these things are going towards it. So that's going to be our slightly negative side. And then everything else is going to be our slightly positive because all those numbers are lower. And we just want to make sure we write polar. And I forgot to write it for the last one. So just make sure that you write polar on here for us. If it's polar, you have to have these. So by writing these, we understand that it's polar, but just make sure to get full credit on the test you do. Put all that in there. Okay, any questions with that one? All right, awesome. Okay, and then the last one we have is this right here, which is 2.5, 2.1. And with this one, first of all, you technically don't have to write even the numbers down because we've talked about this. If it's a hydrocarbon, it's automatically nonpolar. But for this, we kind of see that we're moving in by 0.4 here. We're moving in by 0.4 here. The arrows are moving, you know, kind of to the same point. They're going to cancel out. So for this, we don't need any of this. We would just say nonpolar. Okay, so whenever you see a hydrocarbon, just think nonpolar. Okay, any questions with that?